Hi everyone, this is Miss Tom with a lesson about solving exponential systems graphically. We're going to be investigating car prices. So let's talk about cars. I know you guys all eventually probably want a car in the future. And did you know that the moment that you drive a new car off the dealer's lot, the car is worth less than what you paid for? So let's say you buy a car. Your first car is worth $20,000. You got a good deal on it. You're driving it off the lot. If for some reason you decide to sell your car the next day, it's no longer worth $20,000. It's probably worth $19,800 because what happened is the car went from new to used. Even if you were only in the car for a few minutes, it's now a used car. It's not new, and people are likely to not pay as much for it. That phenomenon sounds kind of funny. That phenomenon is known as depreciation. So, in red, go ahead and write that down. Next thing is, what happens to that car? It's depreciating, so the car's worth less than what you purchased it for. Is it worthless? No, it's worth less than what you purchased it for. Most cars depreciate over time, meaning their value is less than what you purchased it for. But on the other hand, there are some older models of cars, and those older models of cars actually increase in value over time. Some older cars actually increase in value over time, and this is called appreciation, where it's worth more. Alright, so now let's go ahead and talk about it in the context of a linear model. So in a linear model, we know that we go from 0% to 100%. And the original value is always considered 100%. Original is always considered 100%. And what you're going to notice is that when, let's say you have a depreciation of 5%, when it says depreciation of 5%, that really just means subtracting by 5%. So when you subtract by 5%, are you going to go to the right or are you going to go to the left? Well, decreasing means it gets smaller, right? So since it goes smaller, we're going to go to the left-hand side and say it goes minus 5%. And when you minus 5% from 90 or from 100, you're going to get to 95%. Now, if it decreases and has a value of 95% now, our multiplier, the value that you multiply by, meaning how do you figure out the worth of the car? It's going to be 95%, but usually 95% is written as a decimal. And how do you write 95% as a decimal? Well, let's figure that out. 95% as a decimal is 0.95. That is your multiplier. So now let's look at appreciation. Appreciation is a little different. Appreciation is a good thing because the value increases by, let's say, 5%. So again, we're going to say 5% is the increase in value, which means it's adding by 5%. And I want to remind you again that it goes from 0% to 100%. If you have an increase in 5%, what's happening here? You have an increase of 5%. What's happening is that the value gets larger than 100%. It actually becomes 105%. So that's going to be the new value of the car's worth. So how do you do that? Again, you want to talk about the multiplier. How do you figure out what that means? Well, that means that it is no longer worth 100%, it's worth 105. So 105% looks like this as a percent, but what does it look like as a decimal? As a decimal, it looks like, well, 100% is 1.0. So 105% would be 1.05. And that's how you do appreciation and depreciation. So let's actually go over some real life examples here. Okay? So remember, we're following this notation where we know that A represents the y-intercept. Remember that A represents the y-intercept. And then B represents the multiplier. All right, it's kind of hard to write with this. Okay, here we go. So then we're going to look at this. It says a house. House values, depending on the market, raise in value. So we're going to look at this question. It says a house purchased at $120,000. Wow, that's such a cheap house. This is the starting price of the house, and over time, the value of the house goes up by 6%. So how do we think about that? Remember, because it goes up by 6%, you're adding 6%. So it's no longer worth just 100%. Now it's worth 106%. Okay? So that's what's happening. You start at 100. What's happening? You increase to 106%. So since it's increasing to 106%, how do you write that as a decimal? Well, that's written as 100, which is 1.0.06. That is going to be your multiplier. So how do we write our equation? Our equation is written as f of x. That's the function at which we're trying to find the value of the house. F of x is equal to a value, which is 120,000. That's the start of the house. Then we write our multiplier, and our multiplier is 1 6/100. And then we're going to write that to the x power. So what does this all mean? That means you can figure out the value of the house by looking at this equation. So let's say you want to figure out, well, how much is my house going to raise in 10 years? All you have to do is try to figure out, okay, we're going to go, actually, this is not the right calculator. The right calculator would be using Desmos. Desmos, to the rescue. So if we have f of x, actually, we don't need to write f of x. You can if you want to. It's equal to 120,000, 1.06, and then you raise it to the 10th power. Let's go with y. Let's see. Actually, I don't think we need to write this. We just need to do this. Oh, I think it's is it the comma? There we go. No commas. All right, so that's how much the value of the house. Wow, look at it. It's 214,000. Wow. If that keeps happening, that's great. Your house is worth so much. That's really cool. Okay, anyway, let's continue. It says the number of bacteria in a colony is 180 at noon and increases at a rate of 22% per hour. Notice how it says it started at 180. So that's our y-intercept. Okay, and then it says increases by 22%. So let's write that. We'd say f of x is equal to, it started at a value of 180, then it increases as a rate of 22%. So a common mistake is for people to do this. Is that correct? No. 22% is increasing in value. It's worth a value of increase in 22%. So remember, the original value was 100. If you're going up by 22%, you're actually going to be at 122%. Now, 122% is not written like this. That's very small. How do you write 122%? That's written like this. Everybody see that? So our multiplier is going to be 1 22/100. And then we have our x value like this. Okay? Next one is, it's a car value that has initial price of $12,250, depreciates in value by 11%. So at any point you feel like, you know what, I think I got this, pause the video, unpause, see if you got the right answer. It's kind of like what I do with you guys in class. So try it out. I'm going to do it here, We know it's f of x, but let's read the question. It says a car value has an initial price of $12,250. Okay, that's the initial price, and it depreciates. Notice how it says depreciates by 11%. So remember, like we said earlier, we were at 100, but it depreciates in value. It depreciates in value by 11%. So minus 11%, 100 minus 11% is going to be 89%. So it's 89% of the value now. So how you write that is you go is equal to 12,250 times, what's our multiplier? Our multiplier is not 11%. This is wrong. Our multiplier is not 11%. Our multiplier is after you take away from the original 100. So it's going to be 89%. And then we raise it to the x power because we don't know how much time has passed over the years. Okay, again, one last one here. It says an investment is worth 1,000 and it earns 6% annual interest. Ooh, there's a lot of vocabulary here. 1,000 is what it's worth right now. So I'm going to write f of x is equal to, the initial starting point was 1,000. So let's write that. It was worth 1,000. But it says it earns 6% annual interest. Okay? Since it earns 6% annual interest, what we're going to need to do is we're going to know, well, 6% annual interest means it was originally at 100, but it goes up 6%. So it's now at 106%. Okay? So then that means that we're going to write parentheses 1.06. But then because it's compounded monthly, that means how many months are in a year? There are 12. So we would write 12, and then we would write x. And I know what you're thinking. What, Miss Tom? I don't understand that. Well, here's what's going on. Let's say you have the investment for 2 years. That means x would be 2, right? And so what happens is, if you did that for 2 years, you would say, okay, it was 1,000 times 1.06 and then 12 times the 2 years, right? See that? So then it becomes 24. And isn't that how many months it is? Yes. So this is what we have as our equation for if it occurred in 2 years. Okay, so that's how we write it. You can also make sure there's a little parentheses here, just so that you have that there. Okay, all right, this is our last official question. It's talking about milk prices, okay? And it says the price of milk has steadily increased 5% each year. It's increasing, everybody. So you know if it's increasing, is it worth 5%? No. Remember the little number line thing I've been showing you guys. It goes from 100 to 105%. So how do we write our equation? Our equation is f of x is equal to, what's our starting amount? $3.89. Then in parentheses, we need to write 105% as a decimal. Is that written as 0.5 or 0.95? No, it's written as 1.05. So we write it as 1.05, and then we put the x value. But in this question, it's telling us in 10 years. So that means we have the 389, the 105, and then we put this to the 10th value. Okay, so then now we're going to go ahead and put that into our calculator, our Desmos calculator. Go ahead and click on that link. Apparently you don't need to put the f of x value, so we learned that in this lesson. We're going to go 389 times 1.05, and we're raising that to the 10th power. So we get, it's worth about 633.6, so it's about 6.34 if we round to the nearest hundredths. So it'd be $6.34. Wow, okay. That's how much the milk is worth if it had that situation. Now, next one is, what about if you were trying to find out 5 years ago? Meaning, 5 years ago, what was the price? Okay, so that means we're going to need to do a little bit of calculation here. We're using the same formula, 89, okay, and then here is 1.05. Okay, so let's look at that in terms of like a number line. Yeah, 5 years ago. Okay, so let's say here is now 2020. Here is 10 years from now, 2030. This has a value of 10. This has a value of 0. Does everybody see that? Because now would be considered 0. The next would be 10. So if you do 5 years ago, time would be here, which would be 2015, which was minus 5. So then what would our exponent be in this case? It would be minus 5. So let's find out what that means in terms of dollar amount. What was the price of the milk if we're talking about 5 years ago? So let's go ahead and find that out. Assuming that the depreciation was 5% each year. Okay, so then we're going to raise it to the negative 5 power, and we get it's about $3.05. So that's what we're going to write. It was worth $3.05. Alright everybody, thanks so much for watching. If you have any questions, make sure to come to office hours, and I'll see you guys next time.